For today's lesson, we will be continuing our work with number lines, and today we're going to add fractions and decimals to our work. When we're placing decimals and fractions on number lines, it's no different than when we work with whole numbers. It's just now that we have fractions and decimals. So for number one here, we want to represent the fractions 1/4, 2/4, and 3/4 on a horizontal number line. So again, that horizontal number line goes from left to right. We put the lowest number on the left, and that is 1/4. Then we're going to put on 2/4 because that would be the next one in the list. And if you wanted to, you could simplify that down to 1/2. But since you're given 2/4, you can keep it as 2/4. You don't need to simplify here. And then 3/4. So again, no different than had we placed 1, 2, and 3 on the number line because they all have the same denominator, so the interval is the same. For number 2 here, it says to represent the decimals from 1/10 to 9/10 on a horizontal number line. Use an interval of 1/10 between each pair of decimals. So here when it says use an interval of 1/10, that just tells us what we're going up by. So again, we're going to start with that horizontal number line. Since it says from 1/10, if we remember our previous lesson, when we use the word from, we do include that number. So we start with 1/10, and then since our interval is 1/10, that just means we add 1/10 to the previous number. So 1/10 plus 1/10 is 2/10. We add 1/10 to get 3/10. Add a 1/10 to get 4/10. Add a 1/10 to get 5/10. Add a 1/10 to get 6/10. Add a 1/10 to get 7/10. Add a 1/10 to get 8/10. I'll extend my line a little bit here, and add 1/10 to get 9/10. So again, no different than when we had whole numbers in our previous lesson. Represent the fractions 1/5, 2/5, 3/5, and 4/5 on a vertical number line. So again, when we have a vertical number line, our line needs to go up and down. And since our fractions all have the same denominator, we just kind of look at those as 1, 2, 3, and 4. So we'll put 1/5 down at the bottom. And then for our vertical number lines, if you want to do where you're going every other side or changing sides every other number to help keep your work clean and to kind of avoid having to space these out pretty far, that would be perfectly fine to do. Because with fractions on a vertical number line, it does get a little full, gets a little packed in. So if you want to just switch off on the sides that you put the fraction on, that is perfectly fine to do. Excuse me. Represent the decimals 2, 2 and 2/10, 2 and 4/10, 2 and 6/10. Then we get that dot, 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 and 4. Well, that dot, 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 those 3 dots there, just tells you that that pattern is going to continue. It's just taking all the numbers between 2 and 6/10 and 4 and condensing them down so that we don't have to list every single number. Essentially, that dot, dot, dot just tells us the pattern is continuing. So we start at the bottom, and you could put 2 or 2 and 0/10, either one is fine. So then 2 and 2/10, 2 and 4/10, 2 and 6/10. And then that takes us to the dot, dot, dot. Well, again, that dot, dot, dot just means that that pattern is continuing. And the pattern that we've had here is that we're going up by 2/10. So we go up by another 2/10 to get 2 and 8/10. And then 3 or 3.0, either one's fine. 3 and 2/10, 3 and 4/10, 3 and 6/10, 3 and 8/10. And again, if you have to go into the problem to fit that last one or the last couple in there, that is perfectly fine to do. So here we have fractions and mixed numbers greater than 0 but less than 2, and we want an interval of 1/3 between each pair of numbers. And the directions do tell us to draw a horizontal number line. So I'm going to start with that horizontal number line. Well, if I want fractions and mixed numbers greater than 0 and I have an interval of 1/3, then I start with 1/3. 1/3 plus 1/3 is 2/3. 2/3 plus 1/3 is 3/3, or 1. 1 plus 1/3 is 1 1/3. 1 1/3 plus 1/3 is 1 2/3. Number 2, decimals between 0 and 1 with an interval of 25 hundredths between each pair of decimals. So again, have that horizontal number line. We want to be between 0 and 1, so we don't include it. So if we have an interval of 25 hundredths, we start with 25 hundredths. And then we add 25 hundredths to that, and we could leave it as 5 tenths or 50 hundredths. Either way is fine. And then 75 hundredths. And then for our final example on this slide, decimals greater than 8 but less than 12 with an interval of 8 tenths. So if we want to be greater than 8 and our interval is 8 tenths, then we would have 8 and 8 tenths. And if needed, to find the next one, go ahead and do that addition. Adding decimals is something that you should be able to do. That was our previous, that was work from our previous chapter that we just covered. So this should not be a skill that you are unfamiliar with. You should remember that material from the previous chapter. And just keep adding 8 tenths to the previous number to get the numbers on our number line, which would be 8 and 8 tenths, 9 and 6 tenths, 10 and 4 tenths, and 11 and 2 tenths. We're going to draw a vertical number line to represent each set of numbers now. And so we want mixed numbers greater than 6, but less than 7 with an interval of 1/6. So again, we want a vertical number line, so we're going to start at the bottom, work our way up. So we want to be greater than 6, and our interval is 1/6. So we'd have 6 and 1/6. We add 1/6 to that, and you would get 6 and 2/6, or if you wanted to put 6 and 1/3, that's perfectly fine. Then we have 6 and 3/6, or 6 1/2, 6 and 4/6, or 6 and 2/3, and then 6 and 5/6. Positive fractions, less than 1 with an interval of 1/12 between each pair of fractions. So again, positive means greater than 0, and we have an interval of 1/12. So essentially, we're just putting the numbers 1 through 11, but writing them with a denominator of 12. So we would have 1/12, 2/12, or if you put 1/6, that's fine. 3/12 or 1/4, 4/12 or 1/3, 5/12, 6/12 or half, 7/12, 8/12 or 2 2/3. And remember, if we run out of space, just go up through the problem. So 9/12 or 3/4, 10/12 or 5/6, and finally 11/12. But again, I do want to emphasize that if you're doing a vertical number line and you run out of space, you can just go through any wording, any problems that are there to finish your number line. All right, for our next one here, we did have a slight technical delay, so I had to pause for a minute and fix that because the problem was missing, but now we're back on track. So for our next one, we want to draw a vertical number line to represent decimals greater than 7 and 2/10, but less than 9 and 6/10 with an interval of 3/10. So once again, since we have that vertical number line, we start at the bottom, work our way up. We want to be greater than 7 and 2/10. So we add 3/10 to that, and we get 7 and 5/10. Add 3/10 to that to get 7 and 8/10. Add 3/10 to that to get 8 and 1/10. Add 3/10 to that to get 8 and 4/10. Add 3/10 to that to get 8 and 7/10. Add 3/10 to that to get 9 or 9.0. And add 3/10 to that to get 9 and 3/10. And then finally, we're going to use that knowledge to do some comparisons. And again, comparisons, you're determining which one has more value than the other. So when we have two fractions, when we compare fractions, we kind of follow the same rules as when we're adding or subtracting fractions. When we add or subtract fractions, we need to have a common denominator. So when comparing fractions, it's good to have a common denominator as well. So when we're comparing 2/3 and 5/6, a good common denominator to use would be 6. So 2/3 is equivalent to 4/6. 5/6 can stay the same. 4 is less than 5. So 2/3 would be less than 5/6. When you have two decimals and you compare them, start with your whole numbers. Since our whole numbers are the same, we can't determine if one's larger than the other. So then we go place to place after the decimal point. So we compare the 10th place to the 10th place. Since they're different, 3 is greater than 1. So 1 and 3/10 would be greater than 1 and 15/100. And then when we have two different numbers, we have a fraction and we have a decimal, we have a couple strategies that we can utilize. One strategy is that our proper name of our decimal here is 62/100, which would make that 62 over 100. So a good common denominator to use with 5 and 100 would be 100. So 3/5 would become 60/100. 62/100 is greater than 60/100. Or another option is we know that 3/5 is equivalent to 6/10. 6/10 is written as 0.6. And so 62/100 would be greater than 60/100. So either method is fine. Either converting them both to fractions or converting them both to decimals, you will get the same answer. So here we're going to fill in the blanks on our number line. And if we have 1/100th to start and then 2 spots and then 4/100ths, we know that we're going up by hundredths. So this would be 2/100ths, 3/100ths. Between 5/100ths and 7/100ths would be 6/100ths. After 8/100ths would be 9/100ths. And then after 9/100ths would be 1/10 or 10/100ths. Either one is fine. When we compare, well, 1/10 is more than 5/10, or more than 0/10, excuse me. So 1/10 is more than 5/100ths is what I meant to say there. For part B, whole numbers are the same. 10th place are the same. 2 is less than 7. So 2/100ths is less than 7/100ths. 3/8 compared to 3/4. Well, good common denominator to use would be 8. 3/4 is equivalent to 6/8, so 3/8 is less than 6/8. For number 3, we have mixed numbers. Since the whole numbers are the same, they aren't going to help us determine which one is greater. But we have 9/10 compared to 4/5. Well, 4/5 is equivalent to 8/10. So 3 and 9/10 is greater than 3 and 4/5. For number 4, our decimals, our whole numbers are the same. Our 10th places are different. 1 is less than 7. So 2 and 17/100ths is less than 2 and 71/100ths. For number 5, our whole numbers are different. 14 is greater than 13. For number 6, 0.7 is 7/10, which would be equivalent to 14/20. 3/4 is equivalent to 15/20. Well, 15/20 is greater than 14/20. Or if you knew that 3/4 was equivalent to 75/100ths as a decimal, you could do that as well. For example, we should know that 25/100ths is equivalent to 1/4. 1/5 is 4/20. 1/4 is equivalent to 5/20. 5/20 is less than 4/20, or it's greater than 4/20. I apologize for that. And that is all for today's lesson. As always, I hope this helps.